I'd like to welcome Tom Nguyen, Vice President of Business Development, and William Tenorio, Senior Director, Advanced Battery Systems, both of Inventus Power, who will be speaking today about optimizing powertrain efficiency with lithium-ion battery technology. Welcome, Tom and William. Please take it away.
Thank you, Rod. I appreciate it. I'll just briefly introduce myself again. I'm Tom Nguyen. I'm the Vice President of Business Development. I'm also responsible for our product strategy for advanced battery systems at Inventus Power. I've been in the battery industry for 18 years. Also worked sideways in parallel with Rod at Samsung for 3 years. So understanding the whole electrification strategy and the periods of how this has transitioned over time. William, you'd like to introduce yourself?
Hi everyone. My name is William Tenorio. I'm Senior Director of Engineering for the Advanced Battery Systems Engineering team. My primary focus is on light electric vehicles, but I do have years of experience on battery management systems for different applications, from handheld devices all the way up to buses and trucks, including power distribution as well. So, pleasure.
Thank you, William. For those who are on the webinar, just to introduce a little bit about Inventus Power and who we are. We are a global leader in advanced battery systems. We've been in business for 62 years, 30 of those years in lithium-ion battery technology. We're a US-based company. A lot of our focus is on highly engineered solutions, supporting kind of on various markets and demands here. I'm responsible for more of our light electric vehicle portfolio, but if you can see on the diversification of the market segments we participate in, from the medical class 1 to class 3, all the way to construction and military, we're pretty diversified in a lot of our standard and custom OEM products. And the benefit of that is we develop, design, and manufacture all of that focused on purely on safety. Today, what you're going to learn is we're going to highlight some of the critical factors of what to consider when transitioning from a conventional internal combustion engine to a fully electric powertrain utilizing lithium-ion battery technology. From a stance, when you look at kind of the market shift in how it's been transitioning on the electrification period, you look at internal combustion engines, which has been in existence for centuries. When you look at that, that's already transitioned within hybrid electric within the past 15 to 20 years. But there has been a momentum, there has been a shift and evolution of where you can see a lot of the many OEMs, great presentations throughout the webinar, but kind of examples for golf, aerial work platform, lawn and garden, floor cleaning, material handling, and also going into the passenger vehicle side of the business. So there has been a paradigm shift because the need and the wants of kind of creating more of a sustainable energy across the globe. The irony of this is when you look at some of the combustion engine, as I highlighted on the slide of the H2 Hummer, now the world's also transitioning that vehicle into electric. But that's better. What we're kind of focused towards is trying to understand what does that mean from the market shifts, and then how do we work on that, the infrastructure to kind of support the electrification across the globe. When we look at various electric vehicle types, there are 3 types that we've seen, and we've highlighted more the hybrid electric, plug-in hybrid electric, and full battery electric. There's 3 goals of what we're really trying to achieve on here. And as you can see there, everything that's comprised from gas and going to full electric, it's really 3 variables we're trying to drive for higher efficiency. To doing so, we're always looking at assessing how do you optimize the powertrain? How do you eliminate energy idling? Right now, as we see energy idling in gas engine vehicles, that's contributing to around 60 to 75% losses there. Hence the development of HEV and PHEV development. But a lot of that on the ecosystem is also leveraging from the regen braking to optimize the performance and the metrics and longevity of these systems. The elimination of maintenance, going from combustion engine, when you're looking at typically having vehicles with gas, spark plugs, filters, how do you minimize or reduce the amount of moving components in the vehicle, right? To create a longer life cycle. And then third bullet point of sustainability. Really, the end goal for us is to kind of drive and gear towards more of a zero carbon footprint, right? So basically, essentially eliminate the emissions and the reliance on non-renewable gases, resources. So really, we're trying to kind of focus on the strategy for BEV for the future to come. When we look at vehicle performance under various drive cycles, there's a lot of parameters and metrics to understand what does a duty cycle constitute to, whether it's an acceleration, gross vehicle weight, passenger weight, all of that has implications on the range expectation. Of course, temperature is a variable, but it fluctuates based on the region. And part of today's presentation is to understand how do we help leverage the power efficiency with the importance in leveraging that with lithium-ion battery technology. So as we've seen with working with many of our OEMs, there are a lot of differences here. And when you look at considerations, hybrid vehicles and battery electric is more applied to this utility vehicle application. Now I'm going to pause and have a poll taken for the audience here on the next question coming through. Have any of you experienced any difficulties with transitioning from DC to AC powertrain? I'm going to pause for a few seconds, let you address, and then we can continue through the presentation. Okay.
Yeah. So looking at those answers that are rolling in, it seems like some people have had difficulties transitioning to a battery electric vehicle powertrain. And some of the concerns and things you have to consider is that a BEV compared to the others, the other powertrains is, at least to us, it's more elegant, it's beautiful, it's simplified. So some may say, yes, the integration is going to be easier. You have less to worry about. But for us, it's an entire ecosystem of components. So when you look at the battery alone, you have to consider not only who your battery pack manufacturer is, but what they offer. Do they give you the ability to understand what safety really means and how you can modify that for your application and optimize it for efficiency? So from the grid to the output of the terminals, there is specific energy conversion, and that conversion is going to have some efficiency loss. When you look at your typical lead acid batteries, that chemical conversion is usually dissipating a lot of heat. There's a lot of losses associated with that conversion. Whereas with lithium-ion, you get larger efficiencies, and we'll touch on that in a further slide a little bit more. When it comes to motors, we saw from Schaub-Müller, there's still a lot of motors with differing benefits. So if you want low cost, potentially lower efficiency. If you want high cost, higher efficiency, and understanding how that fits within your powertrain selection is very important, because then that drives also how big your battery pack is and how some of the other components that interact with that powertrain will behave. And then the motor controller is important to then manage that motor and manage how it is optimized within the system, which we'll also touch on a little bit more as well. On top of this, the charger, making that critical decision as to whether it's going to be onboard or offboard really depends on what you're trying to achieve. So with some respects, we've seen customers that use an onboard charger as a critical other component that's helping drive that powertrain. Whereas for certain applications where range is extremely critical, we may see that charger being off board and more of a plug and play situation where you bring the vehicle back, you charge the battery pack, and then you're off on your way again. And then when it comes to software, I mentioned safety, but then there's also just understanding energy utilization within your fleets. So this is something that's growing exponentially, and having data and information to understand basically where your battery packs are, where your vehicles are, and how that energy is being consumed can be extremely important to say, oh, these battery packs or these vehicles are not being utilized as efficiently as possible. Why don't we shift our overall utilization plan and enhance what we're doing there so that we can optimize, every dollar that we spend on that energy, basically, right? So this ecosystem is very important, and as Matt stated yesterday, not all batteries are created equal, right? So ultimately, if you're trying to optimize the efficiency with this ecosystem, you really want to try to understand how all of these components, including the software firmware, how that impacts the battery, because then you're really taking into account all of the components. So diving into motors further, we see power maps all the time when we're trying to do integrations, right? And some customers, they'll fall asleep when I talk about this because, they've seen this day in and day out. But for others, this is still a new area when it comes to electrification. How do you balance a motor and what that motor offers with the energy that I have available from a battery pack within my application? And that's something that you need to look at this power map and say, okay, power is torque times speed, but where do I need to operate? So if I have this specific power map for this specific motor, this lends itself more towards a motor that's going to provide higher efficiency at higher RPMs, but not necessarily the greatest efficiency at low RPMs and high torque. So for a utility vehicle where you're transporting passengers or very light loads, maybe this is an ideal motor for you. But if you're trying to do something with a heavy payload that you're trying to pick up and move, then yeah, this motor might not be that efficient. So you have to really look at this and understand, yeah, what is that motor going to offer you? And if that motor specifically doesn't offer that for you, then it becomes a question of, okay, what do I look for? So in the automotive space, we've seen different advancements to use dual motors, right? So in this case, I show, oh, maybe there's another motor that has a higher efficiency region within that high torque value and low speed RPM. So then you can, for takeoff, use that high torque motor. And then as you start getting into the higher speeds, you want that higher efficiency, so you're not consuming that much energy, then you switch to that other motor. Now, some of this is also achieved by using a motor that maybe has an efficiency region somewhat in the middle. And what you do there is possibly use a gearbox transmission with multiple gears or two gears that you can adjust the motor for and make sure you have efficiency where you need it, right? So you're kind of shifting around within that power map to a limited extent, right? Because you're going to be limited by the number of gears that are available to you. But this is all important, right? Because the more you look at this and the more you think, okay, maybe I should put a little bit more emphasis on truly evaluating what's out there in terms of motors, then the more you're going to potentially influence how large that battery pack is. And if you can maybe spend a little bit more on the battery on the motor selection or on the gearbox, maybe that can result in direct savings on the battery pack itself. So we will stop right there and take another poll. So Are you considering transitioning to lithium ion for your electric powertrain?
Pause for a moment, let the audience to provide their comments. Okay.
Okay, it looks like a lot of you are considering lithium ion for your electrification, which makes sense because that's the way a lot of industries are going, and this slide captures a little bit of why that is, right? When you look at traditional lead acid batteries, that grid to chemical output energy efficiency is really fairly low. It's about 60 to 70%, depending on that lead acid technology. When you go to uh, TPPL technology, which has been buzzing around in the industry more recently, that's thin plate pure lead, which is just a variation on lead acid. That gives you a higher efficiency around 80 to 85%. But when you compare that to what you get with lithium ion, then lithium ion gives you the highest efficiency, 92% to 98%. And as you have more development in the anode, cathode, and electrolyte, and even into solid states, all of this is contributing more to higher efficiencies to really pull that chemical energy out. Um, and that's really what's going to drive electrification, right? And as the prices drop, that's also going to help because it's going to make the conversation a lot easier for all of you. And this is just looking at the two technologies, lead acid versus lithium ion, with all things being equal, right? So we show here, transaxle or transmission, which typically is single gear for basic systems, with a DC brushed motor and the motor controller to go along with that. You may see about an 85% efficiency there. Now, with the understanding, sure, DC brush motor isn't really prevalent anymore in the automotive industry. For the light electric vehicle space, we see more AC induction motors, right? So people have moved away from brushed. And what is that reason, right? So we see 85% efficiency here in that powertrain. If you transition to an AC induction motor, you may increase that to 91% efficiency. So there's clearly an overall efficiency increase, and that efficiency increase is only going to contribute to a better efficiency at getting that grid energy out to the wheels, right? So making sure that you're following the full ecosystem and taking advantage of the product selection. Now, as I stated earlier, you can go to a permanent magnet motor or some of the higher cost, higher efficiency motors. So you also heard mention of synchronous reluctance motors, right? So all these are options, and that's only going to increase that efficiency by a few more percentage points. But that few percentage points could still mean a drastic change in the battery pack size. So you definitely want to look into that if you have not, to make sure you're optimizing your electric vehicle powertrain.
So when we look into battery pack sizing, really there's 4 elements that we see as a benefit for sizing based on duty cycles. I'm using a case study here for a utility vehicle where we look at scalability of modules. And the important piece of having modules is to eliminate the need of lift assist equipment. So also the modules also provides levels of communication and protection to increase productivity. A lot of the things that are considered for speed, as an example, when we look at off-road or street legal, anything over 25 miles per hour or anything less than 20 miles per hour. But there has been increasing demand for neighborhood electric vehicles. But again, when we look at utility, what's your payload? What's your grade? How do you increase on that on torque? And basically maximizing the performance. A lot of those deliverables are achieved by driving higher levels of intelligence and efficiency. As William covered, most of the transition period from DC to AC induction is helping with these goals. So for in these real case scenarios, and for what we had from two of the modules, from a 6 kilowatt hour system, scalable up to 12.4. This kind of gives you an idea from the capability with payload capabilities for utility vehicles anywhere under 1,500 pounds. But the essential thing is, how do we maximize that performance? And by having a modular architecture and being able to scale that within the system, it's going to drive that to a deliverable and increasing the needs for the end user. Now, when we covered utility vehicle, now there's the different needs of there's range versus now when you look at the consideration of runtime. So we've also worked with another OEM on a commercial mower that obviously is looking to support almost a full day of runtime. But the goal is that it's, how do I drive that runtime and scalability in more of a hot swappable system? You're still leveraging higher torque and higher terrain because, again, the grades are much more substantial and different, cutting criterias. But to drive a higher intelligence, you have to have a more optimal powertrain system, and also driving that with the motor controller. All these deliverables here to make sure that we have the architecture to enjoy that. Sizing is important, whether you operate on a single use of a 3 kilowatt hour system, scalable up to 15 kilowatt hour architecture. But this kind of gives you an idea from the system needs. Each of the applications have various duty cycles, and we drive the energy density, and we design the power profile to map it according with the powertrain system.
Yeah, and what's great about this example is that when we first put our battery packs in there, you're able to get 30 miles per hour on a lawnmower. But who realistically is going to be cutting their grass at 30 miles per hour? You're probably not going to get a good cut. So this is when it comes back to really, dialing back the requirements and expectations of the system and saying, okay, what's important to me? Safety, the right amount of torque, performance, so that the driver feels comfortable and feels like, they're in control. So all of this that Tom is mentioning is extremely important, but it also contributes once again to that battery pack sizing. So these are conversations that you need to have, and your battery pack manufacturer should support you in that to better understand how you can communicate to the system and utilize that energy from the battery pack efficiently.
And also charging, right? Obviously, with them supporting the necessities of charging and infrastructure, you have to make sure you have the right charging platform to make sure the communications are in dialogue, to make sure that you can support rapid charging or overnight charging, but that handle the capability of the performance for increasing productivity. In this case, we're trying to look at 3 or 4, 8 hours, 5 hours of mowing over 4 to 5 hours, 4 acres. For that consideration.
Yeah, and on that note, for charging, here's the other charging, right? Regenerative braking. So you're already converting energy from the battery, that chemical energy, into the wheels, right? To move the vehicle. Now, if you take that kinetic energy and you have regenerative braking, you can put some of that energy back into chemical energy into the battery, and increase that efficiency, that overall conversion efficiency, right? Now, one of the things that we found as we've been working with partners is that some people do not understand how much they can potentially alter some of the parameters for regenerative braking within the motors. So this is something where you should be having the conversation of, is my regen enabled? Can it be enabled? What are the limits for that regen, and how does that pair up with the battery pack that I've selected to be able to support that regen? And this is important, right? Because you might be able to gain a lot of the losses, right? With an internal combustion engine, you might see 15% to 20% energy loss that goes to the wheels when you're braking, but now you're trying to recover a portion of that and send it back into your electric vehicle system. So, that could definitely have a direct impact on the range, runtime and so on. But that regen, of course, has its limits. It's going to vary based on temperature, drive cycle, state of charge, and the terrain. So you need an intelligent system that's going to be able to communicate. And by intelligent system, I mean an intelligent battery management system that's capable of communicating when is the right time to regen, how much regen energy you can accept, and trying to make it a little bit more dynamic. And one specific use case is cold weather operation. So if you have a cold start, yeah, your cells may have frozen electrolyte. And so you don't want to pump energy into a frozen battery. That is a horrible use case. So communicating to the battery pack as the cells warm up can then tell you, okay, the outside ambient is still extremely cold. It's below zero. But now the battery cells are warm enough to be able to accept regen energy. And now you can take advantage of that to, once again, recoup some of that energy loss. In addition, some of the things we've seen, maybe more in the automotive space, but not necessarily in the light electric vehicle space, is taking that regen energy and distributing it to more efficient components. So what I mean by that is you may have a DC to DC converter that's in the system with a very high efficiency. So it's taking the battery energy and it's pumping out maybe a 12 volt bus, 12 volt DC bus that is providing power to accessories, power steering, radio, and so on. Well, if you instead take some of the regen energy and put it directly to the input of that DC-DC converter, now you're optimizing that efficiency conversion, right? Because you're not sending it back through the motor controller to the battery, where it will now potentially then reverse its path and go through all those components again to get to that DC to DC converter. In some cases, this is inherent based on the vehicle architecture, but being able to understand how much energy is going where, then you can really understand those efficiencies and maximize your powertrain to work effectively.
In addition, this is also with regen strategies William highlighted. This is also going to help prolong the longevity of the battery system. When you look at the scenarios, it's, when you're trying to optimize and reuse that, the performance and all the conditions, the reuse of the energy and directing it back to the battery system usually prolongs that, a longer duration at different SOC levels.
Yeah, and at the high SOC, right, for those that are not aware, if you're at 100% SOC, you don't want to put regen back into your cells. That is a use case where you're trying to pump too much energy into a cell that cannot accept it. And for some people doing electrification, that's a little bit hard to comprehend, right? Because if you're trying to maximize the runtime, you want a wider range of that cell that you're utilizing, but it comes with its drawbacks, because then you may not be able to put regen into the cell at the higher SOC range. However, if you're accounting for, let's say, maximum cycle life and consistent operation across the life of the product, you may bring that range in a little bit. And then what that allows you to do is expand the range over time, right, to be consistent. But then it also allows you to have that range on top, where you can still support some regen, right? Because you're not maximizing the energy content within the cells themselves. So there's always trade-offs that you can make just depending on your application to still really take advantage of the regen energy. But once again, it's one of those conversations you need to have with the battery pack manufacturer to say, oh, how can I alter those components, and how can I receive that communication from the battery pack to really optimize the system? So we talk about efficiency, but one of the most important things about efficiency is making sure you can use your vehicle, right? So if you have downtime, that's not very efficient because you're not utilizing the vehicle. So having a battery management system is really the first key if you're thinking about transitioning to lithium-ion. So there are customers that want to have more of a lead acid implementation, where the lithium ion battery packs will completely behave like a lead acid pack. However, you still want to have communications. Communications is key to understand what's going on with the battery pack. It's going to give you, potential diagnostics, alerts, warnings. And at the system level, if you have that, that's crucial to then making system dynamic changes to prevent faults. And one example is if you're continuously putting your foot on the pedal, that temperature rise on the cells is going to be gradually increasing. Now, if you're coming close to an over temperature condition, if the battery pack is alerting you, well, you might be able to curtail some of that speed so that you don't reach that over temperature fault and leave the user stranded as a result. In addition to that, if you did have, for whatever reason, a fault within a cell, maybe it was a process issue that was a latent fault in the field, that one battery pack might take itself off the system. So Tom had mentioned a modular architecture with battery packs. And in that case, if you do have a faulty cell and it takes out a battery pack, if you have a modular system, now the other battery packs may be able to provide energy in a limp home mode scenario, which allows the user to go back and go back to the garage or to the club and try to understand what's going on with the vehicle and maybe pull that faulty battery and put in another one to replace it so that they can continue doing what they were doing, right? So some of these things are critical to making sure you don't have that downtime. But this is all a combination of having a sophisticated battery management system that can handle some of this. One further piece is understanding how battery packs are provided into an original equipment manufacturer, an OEM, versus an aftermarket use case. So you'll have different powertrain malfunctions possibly because of a battery pack in the aftermarket space that wasn't designed as well to be utilized in the vehicle, that the OEM spent more time integrating and doing validation on. So we heard yesterday, once again, from Matt saying one of the most important things is spending the time to do testing, right? So if you're doing any type of electrification, you have to do validation testing. When transitioning to a different powertrain, even if it's just a lead acid to a lithium ion, it's still a completely different change. So you want to do the due diligence, you want to do the validation testing to ensure that integration is going to be more seamless, and you understand, the parameters of what that powertrain can support. Things to help out with that are things like software, right? So there are CAN open standards, J1939 standards that can be implemented to provide more data out of the batteries to then help support and drive the rest of the powertrain. In addition to that, functional safety and just different levels of protection, whether it's current, voltage, temperature, right? All of this is just going to give you a higher degree of confidence that if something does happen, you're going to be protected. In addition, charger protection, right? So, we don't expect usually for a charger to fault, but if it does, how does the battery pack react? And how does that compare between an OEM pack and an aftermarket pack, right? In some cases, you might be able to get that same OEM pack in the aftermarket, and you don't have to worry about that. But if you are working with a different pack in the aftermarket space, then yeah, you should consider that, because there are aftermarket chargers that may suggest they can provide the same levels of, charge power and protection. But if they were made for a lead acid battery and now you're using it for a lithium ion, there could be subtle differences that could lead to malfunctions down the road that you want to be aware of. On top of that, designing a battery pack to meet, rigid or more environmental conditions that you would expect, when being used outdoors or indoors under, heavier payloads and whatnot. That's very important. So what does that mean? That means having a water ingress protection level that's high enough and suitable enough for your application. But then it also means having a mechanical design that can support shock and vibration to levels for transport, but then also for normal use case within your application, right? So all of this goes into ensuring you have, very minimal powertrain malfunctions down the road as a result.
And kind of William hit on point. When you're looking at applications such as this clean equipment, you're not just going to provide and say, hey, I'm going to drop in a marine product, marine battery, or stationary product. It goes, you have to understand the metrics and the criteria to design for the ruggedness, environmental conditions, the shock and vibration, because it just takes a couple of those over time from a product utilization, the battery could fail. So the whole idea is to kind of design a product that's more universal for motive power, but that could also be leveraged for energy storage. That's kind of the criteria that's been the forefront of how we look at our battery architecture, but also eliminating possible areas of any malfunction within the system. So that kind of recaps everything that we covered today, from energy consumption, from the lithium-ion battery behavior under various drive cycles, and regenerative braking. William did a great job covering a lot of the safety topics. Well, this kind of wraps our conversation, and we'll kind of leave it up to the floor for open questions.
Tom and William, that was great information. Definitely useful knowledge for me to understand when looking at a solution to optimize powertrain efficiency via lithium ion. So to the attendees, if you have any questions, please pose it to the tab where it states Q&A on the top right of your screen. And I guess while we wait on those type of questions, I guess from my perspective, what has been the most challenging hurdle in proposing solutions that match with powertrain efficiency related to lithium ion? Because that's one of the benefits from my perspective. But I guess there's been a lot of challenges that OEMs have faced as they develop their solutions from incumbent power sources. So maybe you guys could elaborate on that.
Yeah, some of the examples is what we've seen in the industry, right? That's a great question. It's being able to make changes in their chassis design, right? Accommodating, because in some cases they have some of the applications in the vehicles have been designed with center of gravity and weight and distribution in mind. But trying to make a complete changeover in decreasing weight, it's a benefit, but sometimes it can adjust the whole architecture from suspension, control, and kind of redeveloping it overall in general from a new product development standpoint. But the energy transfer, or just leveraging lithium, it took years, right, to do a transition, many years to kind of consider. I'll use just a great example to look at lithium for golf carts. That was a discussion for probably over 10 years. But the concern is, how do I need to change out my box tray? Do I need to change out my powertrain? How do I ensure that I have the same level of efficiency to the wheels, and making sure that I can gain the same distribution across the board? Because if you're taking 300 pounds of weight from lead acid to 30 pounds or 40 pounds of lithium, there's a big shift there. And how do you architect that? That's not just for golf. We've seen that into the construction industry. We've seen this into the lawn and garden, where you're taking out an engine, putting a battery system. So some of the challenges is just make sure that the intermediate, there's more of the handshake and alignment of how the power system works all together, right? From fine tuning it to meet the mechanical horsepower and the conversion to electric kilowatt hour. I don't know, William, if you want to add your 2 cents.
Yeah, I think looking at it more from the battery pack perspective, one of the biggest challenges is when a customer comes to us and has already embarked on that electrification journey, but has had issues, with that process, right? And so for us, as we help different customers, we see the different issues that each of them are having, and it's not necessarily, there isn't a playbook that says, oh, this is what everyone is going to experience. And so as Tom talks about, the powertrain, the powertrain varies, the applications vary. So everyone has a host of different problems, and those problems impact the battery in different ways. So being able to manage that diversity of issues and then be able to provide a product that can efficiently address those in a timely manner to get products into production, that can be a challenge. But it's a welcome challenge, because as we continue to support different customers, we're seeing success stories, and that's really positive.
Great, great, great. Thank you for the response. We do have a question here, and I'm just going to publish it. Basically, how do you see the different chemistries, LFP versus NMC, and how will it evolve in the future?
That's a great question. I can take lead on that. I mean, coming from batteries in the past, on the cell side, from Samsung, it really depends on application needs. We do see, a strong shift for NMC, which there's a product roadmap to increase energy density over the next 8 to 10 years. But LFP, it's still, that technology has been in existence for quite some time. But it's just a matter of how much more dense do I need to package it in the right application needs to manage the duty cycle. And so there's a balance there. I mean, we utilize both technologies in our platforms, in our protraction battery systems. And the goal and the need there is that when you tune it in, it's, if it's requiring heavy loading or more energy dense applications. And the goal of that is just to balance that criteria based on the powertrain needs. But I see a shift that both the technologies are going to continue evolving and increasing in size and in energy. But I see it's a balance between the both, and it's all dependent on the vehicle portfolio and the duty cycle.
Yeah, there's definitely different or specific markets that lean more towards LFP, and then there's other markets that lean more towards NMC, NCA chemistries. But that's, as Tom states, based on the application and the use case and overall that temperature rise that you're going to see based on the load profiles. But that's something, we watch closely and we support as needed.
And really, when we look at battery technology, it's how do you design for safety, whether it's LFP, NMC, LTO. That's the number one criteria focus for us, is that safety is first and foremost. Secondary is scaling that energy to maximize productivity, kind of highlighted in our presentation. And you've seen kind of different scenarios there. So a couple of applications, one system is designed, actually both of those systems that's shared in the presentation was an NMC, but we do have other applications with LFP. It's really dependent on what's essential or needed for the customer.
So we see
Is there any other questions to the audience?
Yeah, so we see a question there. What do you find the biggest struggles to be for customers transitioning to lithium?
I don't know, William, you want to take that? I can help.
I think one of the biggest struggles is uh, really finding a battery pack manufacturer that can provide a seamless integration, right? So we hear it all the time. Just like I mentioned before, we started the electrification journey, but this battery pack just doesn't work. So not all battery packs are created equal, right? As we stated earlier, and Matt stated earlier. So you're going to have variations. You're going to have battery packs that were developed for a very specific application or use case, and that may not necessarily translate or convert over to your specific application, right? So if you take a stationary battery pack and now you're trying to use it in a motive application, there's going to be issues with that, and we see that a lot. One of the things that we recommend is making sure that you're asking the right questions to get a more motive designed battery pack to support your needs. Tom, if you want to add to that.
No, I think it's very important. And then the biggest struggle is the integration, right? So there's algorithms, wherein there's software related, there's infrastructure, and how do I make sure that I can leverage it with my existing equipment, compatibility. That's the one. So especially when we look at industries where, hey, I've historically utilized lead acid and I want to do the transition. So part of the benefit of work with what Inventus offers is we have kind of a checklist, checks and balances to offer that from the powertrain, the charging. It's kind of the ecosystem. We're not just mainly focused on the battery system, because part of the transition is to make sure everything is orchestrated properly. That helps minimize the amount of back and forth churn, and it optimizes the system. And so those are the things that we've seen in the industry where those are just kind of leaping into lithium thinking, well, I can just utilize this. The challenge is, well, the battery won't charge. It won't communicate. It turns off. So those are the things that as we learn on those struggles, we collect that, the feedback from the industry. That's why we continue optimizing the battery system to improve the user experience. Part of our battery system is what we offer is that, even though you have a battery system that exists today, our goal is to continue optimizing software to improve usability of the energy over time. So if I have products that's in the field and I see an improvement 2 or 3 years down the line that can give you another 2 years of use or cycle life or performance use, we're going to optimize that through software characteristics. So part of that, and then also the other things is just making sure, one of the other biggest struggles is making sure you're designed for compliance. Having product that services the needs for the US market might not necessarily service the European market. So there's a lot of on-road vehicle safety measures, whether you have on the UL 2580, ECE certification for Europe, or you're designing from other metrics from different levels of EMI certification. But those are the biggest ones that are trying. It's more of an educational piece to the industry. How do you design to those goals? How do you be compliant? And then you can leverage that on future platforms and architectures.
Great, guys. A lot of this is very informative. Good knowledge sharing, and definitely appreciate the time. It doesn't look like there's any more questions coming through. So I guess if there's any closing remarks that you guys want to make, definitely make it, or else, this is pretty much the end of the session.
Now, I would like to thank the Zappy team, the Delta Q team, for inviting us for this webinar. It's been very informative. Hope we get a chance to speak again in the future. I hope that this was very helpful to the audience, and our contact information is on this slide, so feel free to reach out to William or myself for any future questions. Thank you so much for hosting us.
Great.
Thank you.
Appreciate the collaboration and the participation. We definitely look forward to more collaboration in the future. And with that said, this will be the end of the session. As I noted earlier in the top of the session, This is being recorded, so you could view it after the session has ended. Thank you very much, and thank you for attending all of the sessions thus far. Take care.
Thank you.